My name is Robert Mitchell, and this is a project on precision planter seed meteor troubleshooting. All right, so this research project was to analyze the performance of a precision planter that ABAC has. It's a Harvest International planter that's used for all the demo plots over at the ABAC farm. The professors that do demo plots over there have seen where that the target populations have not been met to their standards with compensation of germination rates. So we went in and looked at, we're going to see, run a few tests seeing what the RPM of the seed plate is compared to what the given value is in the power control module. And we used a slow motion camera to see if there's any lag getting up to speed. There was no lag whatsoever, and all that was thrown out the window. So we went all the way down to, we skipped, we pretty much said that the first part of the experiment was null because it just not significant. We came to measuring seed populations with seed output. So I used a couple methods for this. I did 30 seconds, and I held. I captured all the seeds that come out in 30 seconds for 4 different target populations, which would be 20,000, 30,000, 40,000, 50,000 seeds per acre. I used a scale, which has turned out to be the most accurate, to measure how many seeds came out. I hand counted some. I used a seed tube sensor, and then the scale came out to be the most efficient and the most accurate, 98 to 99% accuracy. So as far as what we're studying, what we're looking at is a seed meter, which is made up of a control module. For our precision seed meters, made up of a control module, an electric drive, a seed plate, and a vacuum. So over to the results of what we did for our 4 different target populations. This 1-to-1 line represents what we should be observing coming out of the planter. And our measured data, as you can see, trends below this 1-to-1 line. This second graph shows the residual of how far off. So for our 20,000, you can see it was somewhere between 1,600 seeds off, which that's 1,600 plants less than what you would need. As far as this goes for the grower, different seed populations allow different management practices, not so much as far as yield, but your yield is impacted because the management is not optimal for this population. So going down to efficiency, you can see for 20,000, this is going to be 92%. So across all of these, this is 93%, 92, 91, 92. Across all 4 of these populations, they average out to be about 8% lower than what we need it to be. So from these results, we can see that target rates were not reached across the board on any population, and it was consistent. So which this means to us as somebody who's researching, trying to figure out what's going on, is this could be systematic, meaning that it's something in the chain, some calibration. Our next steps in this study, this research, would try different seed plates, different seeds, perform more field tests, run the planter more, investigate into the monitorization of singulation, seeing if our vacuum is holding those seeds to the plate. Look into our sensors. Our sensors may be giving off false readings, and then we can cross-reference all of this data at the end result to see how much we are affected by these target rates being off.